So we've spent some time talking about breaking down amino acids and basically funneling things into either aspartic acid or glutamic acid so that we can dispose of that nitrogen in the urea cycle. Well, let's think about the anabolic side of this and how we build amino acids. So highlighting here just in this little table, you don't need to know these details, but I do want you to sort of remember that we're about a 50-50 split between amino acids that are essential, meaning we must consume them in our diet, and those that are non-essential, meaning that we can make them ourselves. So the question is how do we then build amino acids that we need? And what we're really going to be talking about then is that we need to have to build any given amino acid, the corresponding alpha keto acid skeleton, and then we can use transaminase chemistry. Rather than funneling down to just aspartic acid or glutamic acid, we can use specifically glutamic acid as a nitrogen source to build any existing amino acid as long as we have the corresponding alpha keto acid skeleton. So let's talk about what I mean here. Let's draw the structure of glutamic acid. So a structure of glutamic acid here. All right, we're going to have the structure of glutamic acid providing the nitrogen source so that we can take any alpha keto acid, assuming we have that alpha keto acid. We can generate any new amino acid that we want by allowing that nitrogen from glutamic acid via transamination chemistry to generate that new amino acid, and then we're going to be left with alpha ketoglutarate. So remembering, we did this in this direction when we were talking about the catabolism of amino acids. We were breaking down our 18 amino acids by combining them with alpha ketoglutarate, transamination chemistry, funneling things down to either glutamic acid here, which is what we have here, or aspartic acid if we're using oxaloacetate as that alpha keto acid. So the key here in this story is recognizing that since glutamate is such an important building block in that recipe to build and generate amino acids, we actually have a taste for E. We have a taste for glutamic acid, and that is the fifth sort of taste sense, which is umami. We have sweet, salty, bitter, sour. And if you think about all of those taste receptors are designed to help us either take in things that we need. Things that are sweet are probably healthy for us. I shouldn't say healthy in terms of today's, diet, but if something that was sampled and tasted as a food product, thousands of years ago tasted sweet, it probably meant that it had nutritional value for us. Same thing with salts, right? Salts are things that we need to take in as a micronutrient. But things that are sour or bitter tend to be things that are poison. So we're hardwired to sort of bring in things that are good for us and avoid things that are bad. Well, here's a fifth example of something that is good and necessary for us. That umami flavor is thought of as savory. And so that is something that we are hardwired to say, hey, this is a building block for something that we need. So let's make sure that we can sense and taste things that contain this and know that that's something that we'd want to eat. Well, here is where we see a flavor enhancer, MSG. Maybe you've heard of MSG. That's an important flavor enhancer. Okay, and let's understand why it's called MSG. Let's draw the structure of MSG. All right. Here is the structure of MSG. And you might be like, well, Dr. Prenny, you just drew glutamic acid again, and you're absolutely right. I drew glutamate, and I drew it with one monosodium. So monosodium glutamate. So that amino acid has a net charge of -1, so you combine it with one cation to make a salt, and you have monosodium glutamate, MSG. So it is put into foods as an additive, as a flavor enhancer to make them more savory. But that's the reason why, is because we are hardwired to have glutamic acid be something that we recognize as tasty and something that we'd want to eat. So sort of paired with this story is the thought of, well, what if you consume too much glutamate. And there are people who are sensitive to MSG who will have certain sort of physiological responses if they've consumed foods that have a large amount of MSG. So the key here is that too much MSG or too much E can be bad. And here's the biochemistry for trying to understand why. Is glutamic acid is actually something that's used to make neurotransmitters. So again, if you've got excess levels of monosodium glutamate, MSG, that you've consumed, it could be a logical sequence of events that you would have too many of those neurotransmitters that are synthesized. So excess levels of neurotransmitters can lead to overstimulation of neurons. Okay, and overstimulation of neurons can lead to some of the symptoms that people experience if they are sensitive or hypersensitive to MSG. Pain, headache, flushing. Okay, so all of this can lead to those physiological symptoms. Pain, headache, and flushing. Sort of an interesting little side note is there is research that's currently being done that actually links MSG with chronic pain. So individuals who may be experiencing chronic pain may experience symptom relief if they find ways to eliminate excess levels of glutamate, specifically MSG as a food additive, from their diet. So that is the story of umami and glutamate.